the topic today is differential technique 1, which is really product rule and quotient rule, higher order derivatives, and the absolute value and the derivative of the absolute value function. This corresponds to sections 3.3 and 3.4 in our textbook. So really what we're doing today is we're kind of giving you more tools for your toolbox so you can evaluate the derivative of different functions. So we're looking first at the product rule. When two functions are multiplied together, how to take the derivative of those. And then the quotient rule. When two functions are divided and you can't simplify them down like we have in the past, how to take the derivative of those. And what I use as a method of thinking for these is that they're puzzles. You got to get your puzzle pieces, put your puzzle pieces together, okay? So if we have the derivative, so d dx of f times g, so the derivative of two functions multiplied, you get f prime times g and f times g prime. You add them together. Now addition is commutative. So 3 plus 2, the same as 2 plus 3. So you might see them reversed, f times g prime plus g times f prime. Alright, either way is good. But what I find that helps is to get kind of a box method, and the box helps organize the thought process. So I'll show you how that works. So here we have h of x is quantity 3x minus 2x squared times quantity 5 plus 4x. So what I want to do first, I want to identify the two functions being multiplied together. So in this problem, it's pretty self-evident. The quantity 3x minus 2x squared, call that f of x. Quantity 5 plus 4x, call that g of x. And you will see different ways of denoting these. You may see instead just f and g. One thing I remember from my Calculus 2 course, the professor would use u and v because they look so different, so they're very easy to distinguish. So let's create what I call the box. It'll help with the organization. I'll use f of x and g of x for this problem. So f of x is the first quantity, 3x minus 2x squared. G of x is then 5 plus 4x. So now the method for these is say they're a puzzle. Got to get your puzzle pieces, put your puzzle pieces together. So let's get our puzzle pieces. We have f and g. Let's take f prime of x and g prime of x. So derivative of f of x, pretty simple, 3 minus 4x. Derivative of g of x, 5 plus 4x, pretty simple, just 4. The 5 goes away, 4x becomes 4. So we have our puzzle pieces. Now put our puzzle pieces together. So what I like to do, I like to kind of do an X. So first, I'll connect these diagonals. So h prime of x, the overall derivative, is f and g prime, so quantity 3x minus x squared, 2x squared, sorry, and g prime, which is 4, plus, then I'll do my other diagonal. So I'll do quantity 3 minus 4x and quantity 5 plus 4x. And there I have my solution, h prime. If it was a multiple choice, you have to simplify it down, so distribute, combine like terms, you can do that. For an FRQ, you can leave that like it is, just that kind of string of quantities put together. Now, you may notice what I wrote for my boxed answer may not quite match either of the given formulas, but for the product rule, that's okay. Addition is commutative and multiplication is commutative. So you can mix the orders a little bit, either in the products or in the addition. You can mix those around because both of those operations are commutative. Now, did we have to use the product rule for that problem? If you look at it, you think immediately FOIL, distribute, expand, combine like terms, then take the derivative using the sum and difference and power rules. Go ahead. For this problem, there are multiple ways to solve it, okay? Sometimes there aren't multiple ways. You just gotta go with what you're given. This is a pretty good example. Y equals x sine of x. It looks pretty simple, but it is a product rule. A way you can help yourself is to quietly to yourself, not loudly, so people around you don't hear you talking to yourself and think thoughts about you. Quietly read it to yourself. Y equals x times sine of x. Now, x times sine of x times product rule. So we have our first function, and then we have our second function, x times sine of x. So let's see, f is x, g is sine of x. So now get your puzzle pieces. F prime is 1, g prime is cosine x. And then put your puzzle pieces together. So that first diagonal, so y prime is x cosine of x. And then you go second diagonal. 1 times sine of x, just plus sine of x. There you go. Okay, so it's a simple looking problem, but when you read it, when you see it for what it is a product rule problem. Example B, we have a couple of different things going on. Now, I've said this before, I'll say it again now, I'll say it again in the future. A lot of derivative problems, you're using more than one rule. So overall, think about what kind of derivative rule this is. We have 2x times cosine x minus 2 sine of x. So overall, what is the big picture for this? Overall, we're looking at a sum and difference problem. We have two functions, the 2x cosine x, and the 2 sin x being subtracted, so a sum and difference. Now within those pieces, like the first piece, 2x times cosine x, there we have a product rule. So you have to evaluate that product rule. So u can be 2x, v can be cosine x, so then u prime is 2, v prime is negative sin x, and then you got to go and put those pieces together. Got your puzzle pieces, put your puzzle pieces together. Once you get to that, you have to remember to go back. The 2 sin x, got to bring that down to the problem, because overall you have a sum and difference, okay? So kind of evaluate this piece first, the 2x cosine x. So evaluate that using product rule. Then once you do that, don't forget about your 2 sin x, bringing that down, okay? So multiple rules you got to keep track of and do them a piece at a time. The quotient rule. So the derivative with respect to x of fx divided by g of x, f prime x gx minus f of x g prime x over g of x squared. So that's a lot. To remember that, I have a rhyme that doesn't rhyme. So I have, this is the same. How I remember it and how I want you to remember it is low d high minus high d low all over low squared. So it's a rhyme you can use. Low d high minus high d low over low squared. It's a rhyme that doesn't rhyme, but it has the kind of a rhythm it can. It's low d high minus high d low all over low squared. Alright, low d high minus high d low all over low squared. And it's important you remember that order, because this subtraction right here, remember, subtraction is not commutative. So you need low d high first, then minus high d low. But same as the product rule, it's a puzzle. Get your puzzle pieces, put your puzzle pieces together. So I'll kind of use the low d high, high d low over low squared, use that nomenclature for the box. So low being the function in the bottom, the low function, high being the function on top, the high function. So low would be x squared minus 1. High would be 5x plus 2. So let's do that real quick. So high is 5x plus 2. Low is x squared minus 1. So then d high, the derivative of the high, be 5. D low, the derivative of the low would be 2x. And then put the puzzle pieces together. So we need low d high. So low x squared minus 1. D high is 5. Minus high d low. So high is 5x minus 2. Or sorry, plus 2. D low is 2x. All over low squared. So x squared plus 1, quantity squared. And there you have it. If it's a multiple choice, you maybe gotta simplify it down more to match one of the 4 answer choices. If it's an FRQ, you can leave it just like that. Low d high minus high d low all over low squared. The problems you are given may look different, but it's the same process, the same like plan of attack. So 3 minus x to the negative 1 over x plus 5. Just look at your high, look at your low, need your d high, d low, put the puzzle pieces all together. At this point, I do want to kind of point out it's a little out of the way of the notes, but my favorite derivative rule ever. The derivative with respect to x of e to the x. So the natural exponential function, okay? Now, you may be thinking, why is it the natural exponential function? Here's why, okay? The derivative of e to the x, the rate of change, so e to the power of x has a slope at any x value of e to the x. The rate of change is also the position. Now, kind of carry that thinking forward. What is the rate of change of the rate of change? It would also be e to the x. So a function, the position, is also the velocity, first derivative, is also the acceleration, the second derivative. It's a natural balanced function. So the natural exponential. Now, quotient rule isn't always required. You could rewrite what you have, kind of look at this fraction, break it up. The x squared over 6, take that. The 3x over 6, take that. And you could get 1/6 x squared plus 1/2 x. Alright, and then no quotient rule required, just doing the product, the power rule with the sum and difference. Down here, same thing. So the -3 and the 7x. Then the 3x minus 2x squared all over 7x. So kind of taking it one piece at a time. Well, I'm sorry, you could break it up more. Just check my notes. This 7x, you could break that up as well. So -3 just over the 7. 3x minus 2x squared, all of that just over the x. I thought I could break it more. Check my notes. You can. Alright, good deal. So -3 over 7. Then 3x minus 2x squared all over x. You can cancel an x out of every term. So 3 minus 2x. You could then distribute the -3/7 and take the derivative from there. So if you can simplify it down before you take the derivative, that is usually a good move, okay? Higher order derivatives, just kind of linking the first derivative is velocity, second derivative is acceleration, and so on. So some physics applications. The moon has no atmosphere, there's no air resistance. The position of an object falling in the moon can be represented there. And then what is the ratio of the Earth's gravitational force to the moon? Remember, gravity is due to acceleration. So if you have S of t, you need S prime of t, and then you need S double prime. And then compare that in a ratio to the gravitational force on Earth, which this is given in feet or meters, given in meters. So Earth's Remember that acceleration due to gravity? Negative 9.8 meters squared per second. Compare the moon, compare the earth, get a ratio for that. For absolute value, remember absolute value has that V shape, so you have two different derivatives on either side of that point where the change happens. So usually that point is at the origin, okay? For this function, 2x minus 5, absolute value, 2x minus 5, that V is going to happen at 5 halves. Alright, so we have a shift over. And now I just want to be sure I'm graphing this correctly. So I'm going to check real quick. Just make sure I have that correct. So 2x minus 5, window, graph. Alright, good deal. So you got the V shape shifted to the right at 5 halves. So again, to zoom in. X equals 5 halves. Set what's in there, 2x minus 5 equal to 0, solve. You see how far over to the right it'll be shifted. So that means, it's going to zoom out here, get the box, alright. So f of x, you could write that as a piecewise function. We have 2x minus 5 with that positive slope when x is greater than or equal to 5 halves. Then we have the negative 2x minus 5, so the absolute value going down when x is less than 5 halves. So if you wanted to take f prime, just take the derivative of each piece of that. So we have 2, we have negative 2. When x is greater than 5 halves, and when x is less than 5 halves. So that absolute value, you would split that up into the right side and the left side.